Now we want to discuss Hibernate from the developer's point of view. 5 things need to be done by the developer. He needs to get her hands on the Hibernate libraries. The database needs to be configured in a certain way. All relevant classes for persistent objects need to be enabled for Hibernate in a certain way. A mapping needs to be given from classes to database tables, and CRUD code on persistent objects need to be written in a certain way. Okay, let's look at the libraries first. Well, we somehow need to download the various libraries for Hibernate, and in effect this boils down to 2 libraries. I mean the Hibernate jar itself, but also the HyperSQL database jar, assuming that we want to use that database engine. However, transitively we need a few more jars, and if you use the sample distribution that goes with this lecture, all these jars are already included. But if you set up a new application, you might need to download these or even additional jars. Other than that, it's just the usual story. So you need to collect all the jars, add them to the build path of your application, and there we go. Now, how do we configure the database, or how do we marry Hibernate, the application, and the database engine? Well, obviously Hibernate relies on a relational database management system for the persistency. So first thing is we need to make a choice here. The simple option for development and testing is to use the HyperSQL database engine. In theory, you can use any SQL database engine, at least any such engine that's GDBC compliant. We go for HyperSQL here in the SQL. So how do you use HyperSQL in your application? Well, I mean, this is a recipe. So we assume that we designate some directory, let's say the data subdirectory, for the database files. And within that directory, we start a database server. So the server is part of the HyperSQL DB jar. And as you see here in this command line, there's a certain class you need to invoke. Okay, and then you just keep the database engine running. So we can now start our Hibernate application as many times as we wish, and the server just keeps running. If we want to see how the database actually looks like, I mean what tables might be added, or what content, I mean what instance might end up in the database, we can use the HyperSQL's database manager, which is a sort of SQL monitor. And here again you see the command line to invoke the database manager. Okay. Now we also need to tell Hibernate what database engine we use and a few other details. So this is the Hibernate configuration file that we need to set up. As you see here, we point to the driver, to the GDBC driver that's used in our setup, and we also tell Hibernate how to connect to the database engine, to the database server. We also give it login details, the username, the system administrator in this case, and empty password, and some other details. Actually, one detail is worth pointing out down here. So with this line, we tell Hibernate that tables would be dropped if they're already there and recreated each time we start the Hibernate application. So once we have sort of populated the database with our relational schemas, and once we actually have started to store data in the database, we might want to disable that line. Okay, so now how do we Hibernate enable classes? That's pretty easy. A Hibernate enabled class is essentially a poser, or plain old Java object style class. So the only thing is we need to provide a default constructor, which is used by the framework, by the Hibernate framework, when, for example, query results are casted to our class types. And also we need to set up a field for each such class a sort of an ID field of type long that serves for the primary key in the database. So that field must have a public getter and a private setter. Here's an example. This is the Hibernate enabled class for events in our event manager application. As you see, this is just a plain old Java object style class. So we have that ID field here for the primary key, and we have the other private fields here for any data that's appropriate in an event class, such as title and date. We have the default constructor here, and we have the various getters and setters here, both for the ID field and for the normal event fields. So there's nothing special here. Now we need to map those Hibernate enabled classes to database tables. So we have to write one mapping file per class. So there's a convention here with regard to the extension that we need to use, and this mapping file must be next to the Java file, somewhere in the file system preferably. So here we see an excerpt of the mapping file for the event class. So you see here how we point to the relevant class and how we point out the corresponding table. So the structure of this XML file here is basically that now the children elements of this class element deal with the various properties of an event object. So the first one here is about the ID field of an event object. So we point to the corresponding field in the class, and we also point out the name within the table and some other details that I will not talk about here. And then you see we have more properties below this class element, more property elements that indeed deal with the remaining elements of with the remaining properties of the event class. So you see that the mapping for the title property is pretty straightforward, whereas for the date property we provide some details such as a specific type, and we also use a slightly different name in the database. Okay. Final step now is to write CRUD code that actually uses those persistent objects. CRUD in the sense of create, read, update, delete persistent objects. This follows, this sort of code needs to follow a certain scheme, such as that we need to get our hands on the session, on the Hibernate session. We rely on a Hibernate utility class here, you find in the sample distribution. And then, at least whenever we want to sort of update or insert or delete something in the database, we might want to start a transaction. So in this case, we plan to add an event, so create and store event. We plan to add an event. So we begin a transaction, we create an object, we populate the object. We tell Hibernate that this object, this new object, should be saved, should be persisted. And now we actually commit that transaction. We return the primary key that's filled in by Hibernate. We return this as the result of this operation. Or here's another example where we plan to add a certain person identified by person ID to a certain event also identified by its primary key. So again, we sort of get our hands on the session, we begin a transaction, we look up the person by person ID, and here we look up the event in a slightly different manner. So here we use a sort of a JDBC style query, whereas here we use the .load method of the session where we tell it the type and the primary key to look up. So these are sort of two alternative methods of looking up objects from the database. Okay, so we are done with looking up the person and the event. Now we can go on and add the event to the person, and this update we reflect it, we tell it to Hibernate by again organizing a transaction and telling Hibernate explicitly that we updated this person, and we finished the transaction.